So let's talk about some of the dinosaurs that we can see in the Cretaceous. So we're moving into question 5 or 45. Let's take a look at the theropods. So one theropod that we find from the Cretaceous is Ornithomimus. And Ornithomimus, its name means bird mimic because it's very bird-like in nature. If you look at it and you've put feathers all over this, I think you can easily see how it would look like an ostrich. But what's really impressive about Ornithomimus is look at these legs. It's got really, really long legs and really, really long arms. Well, these legs definitely tell us that this was a fast runner. So this is definitely a quick-moving, fast dinosaur. And for a long time, the long arms really perplexed people. A lot of people thought that maybe this was a dinosaur that climbed trees, and commonly that's where we find it. But we know that's not the case. This is just definitely a very swift-moving theropod. Next, we can take a look at Deinonychus. And Deinonychus, its name means terrible claw because of this big claw here on the lower foot. Now, this claw, for a long time, paleontologists thought that this claw was used for slashing, right? That this dinosaur would kind of jump up on the back of a large sauropod and just go to town and just slash like crazy. We now know that that's actually not the case. What this dinosaur is probably doing is it's jumping on the back of a large dinosaur and it's using these claws to kind of as a hold on, right? So it's kind of using them and stabbing them in to the sides and just kind of hanging on until the animal bleeds out, which is really similar to how we see, say, lionesses taking down large animals in Africa. It's pretty much the same thing. Remember, biology is all about the it's about the game of energy conservation. Right? You don't really save a lot of energy if you're slashing at something, but you do save a lot of energy if you can jump on the back of something and just wait for it to bleed out. So that's essentially what's going on here. And I would just like to mention that I really need to redo some of these lectures because now we know that most of these dinosaurs actually had feathers. Right? So Deinonychus was not immune to this. Deinonychus definitely was rocking some feathers as well. Next, we can take a look at Velociraptor, which most people know because of Jurassic Park, even though this is a Cretaceous dinosaur. Its name means speedy thief because it's actually really small. And unlike what Jurassic Park says, this dinosaur was maybe 4 feet tall. So this is not a very large dinosaur at all. It's not quite human-sized. But Velociraptor is definitely related to birds. We know Velociraptor, without a doubt, definitely had feathers. It doesn't mean that Velociraptor could fly, but it had feathers. Remember, feathers are just modified scales, right? That's all they are. But Velociraptor definitely used its claw to stab and not slash, just like we talked about with Deinonychus. And then we can end here with the big and famous one that everybody likes, and that's T-Rex. Right, so T-Rex actually wasn't around for very long. It evolved 65 million years ago, and dinosaurs went extinct 65 million years ago. So as it turns out, T-Rex actually wasn't around for very long at all. But T-Rex definitely has a very large head, balanced by this relatively short body. This is a famous skeleton at the Field Museum. This is Sue. This is the largest T-Rex that we know of. Definitely a very large dinosaur, and most complete dinosaur as well. If you want Sue's full story, you can look it up on Google. She has a very interesting and complicated story as to where the fossils come from. So I would encourage you to Google that. But what's really cool about theropods and dinosaurs in general is sometimes we can tell whether it's a male or female. Traditionally with T-Rex, we've always been able to sex them because males are very slender and females are much more robust. Sue is definitely a female, to give you an idea there. So the females are more robust, right, because they're the ones laying the eggs. So that was really one of the easiest ways to sex a T-Rex. However, now we also know that there's another way to do that, and that's by looking for certain types of bone that's deposited. So birds do this as well. When an animal, if we take a look, let's say this is a cross-section of a bone. When an animal is getting ready to lay an egg, right, or make an egg, it lays down this bone right here called medullary bone. It's a special bone, and it's kind of like a vitamin, right? It prevents the bird or the dinosaur or the reptile from absorbing its bone, right, in order to make the egg. So if you find medullary bone, you definitely know you're looking at a female. And it turns out we can see that with dinosaurs as well, right? If the dinosaur died as it was getting ready to lay an egg and we see the presence of medullary bone, oh, well, then we know we have a female. And Sue definitely shows the presence of medullary bone. Like I said, Sue is definitely a very famous dinosaur, and I was very lucky to have worked on Sue at the Field Museum. So there you go. My back was in National Geographic. We were taking pictures, so there's a very young 17-year-old Jackie right there in the background. So there you go, famous back.